Hello, my name is Julia Igasheva. I'm from Yekaterinburg, and my project is aimed to reveal the relationship between physics and statistics by making a three-sided dice. Using symmetrical solids such as a flat coin, a cube, or a tetrahedron as a dice, it's not difficult to determine the probability of each phase. In the case of a cylindrical dice with non-zero thickness, the probability of the phase and side depends on the physical and geometrical parameters of the dice and way of tossing. It's important to say that it's not easy to create a fair dice, for which the probability of the side equals to the total probability of both faces. There are two theoretical models that describe the probability of a dice. The first assumes that the normal to the face of the tossed dice can rotate freely in one plane. We will call it the 2D model. The result of the toss depends on the position of the center of gravity relative to the perpendicular in the impact point. To obtain the probability of side, we calculate the ratio of the plane angles corresponding to the side and face of the dice. The ratio equals to 2 for the fair dice. We will call the second model the 3D model. We will shake the dice before the toss. The normal to the face will rotate not only in one plane. Here we assume that the dice is surrounded by an imaginable sphere whose radius is the same as the radius of the dice. The toss is equivalent to the rolling sphere. When the rolling stops, the sphere disappears. The dice will stay in position on side or on face. To obtain the probabilities of this position, we calculate the ratio of solid angles. The ratio in this case equals to 1.15. Only the collisions of the dice with solid surface can make the dice to change the plane of the rotation. So, if there are no collisions, the 2D model is feasible. The 3D model describes the process well in the case of the multiply collisions. Since it's difficult to predict the number of collisions, we decided to use a special device, a dice tower, in which number of collisions is large enough. Printed 9 dices with different aspect ratios epsilon, 4 dices with the same epsilon but different sizes, and 8 dices with the same size but different weights. We can conclude that the probability of the side doesn't depend on the linear sizes and mass of the dice. The probability on this graph is calculated for the total amount of tosses for 400. Using our dice tower, we determine the experimental probabilities of the side for the different dices. The blue and red lines correspond here to the 2D and 3D models respectively. It turns out that only the dice with an aspect ratio of 1.4, which is approximately square root of 2, meets the fair dice conditions. So in our study we proposed 2D and 3D models of dice toss. To make the distribution of the dice velocity constant and independent on the initial condition, we use the dice tower. Our experiments give us the value of the aspect ratio of square root of 2, which is between the values calculated in 2D and 3D models.